Today we are going to start with MLFlow. So the things that we discussed: Python, ML code. Here we are basically talking about pipelines. This is the important concept that we have discussed. With respect to the deployment stages we are speaking of. So these are all the new things that we have learned. So Python code, in that we need to speak about pipelines. Then we talked about Flask. This is for web UI. Then we discussed about containers. And here we discussed about Docker and Docker images. Then we discussed about Kubernetes. Right, so these are the different things that we discussed. And post that, we talked about Kubeflow. Kubeflow has its own, I should say, constraints with respect to the implementation in day-to-day scenarios. If you have to use Kubeflow, then there is a lot of setup-related challenges that we will have to work through. It's still naive at naive stages. It requires to mature a lot, though people have started using it because of its open source nature, and right, it's basically compatible with GCP. But as we have seen, it has its own challenges, right? So that's something that we have to understand. Kubeflow is a little tricky one, but we also have alternatives to Kubeflow. Right? Couple of the alternatives that we will be discussing are MLFlow and TFX. All right, so these are the two things that we will be discussing. MLFlow is something that we are going to start now. So when we talk about Kubeflow or MLFlow or TFX, the primary agenda of these tools or packages or frameworks, you can say, are basically to ensure that end-to-end ML workflow can be implemented. We are talking about ML workflow. That means the process that we need to follow while developing the machine learning models is to be standardized. And that's the idea of these tools. Kubeflow, of course, has an additional capability that it can also manage the hardware. Right? It works with Kubernetes, but it ensures that the auto-scaling capability of Kubernetes is used whenever, wherever it is required in the machine learning phases. Now let us talk about MLFlow. MLFlow, machine learning flow. Again, this is also designed to ensure that we follow crisp MLQ methodology and try and design, develop, train, tune, and deploy a machine learning model. Now, when we talk about your machine learning model, I can broadly split that into train and deploy. Okay, at a high level, at a very, very high level, we are splitting it at train and deploy. So this is where we will be doing a lot of experimentation. And once we get the best model, that best model has to be productionized. But that means here we will have a lot of iterations, a lot of rigmarole happens with respect to data, with respect to the parameters, with respect to your model selection itself, machine learning model itself. Now, for example, you take some data. This is a sample data which is given to your given by your business for your development. I mean, for your team, so that you can develop machine learning models. So this is some data that you received. What you do, you clean the data, then you basically arrange or organize the data. You can say both these two steps are combined, and post that you develop machine learning model. Train. Here at this step, you basically split the data into train, test, or train, validation, and test. And then here you're training your model. And then you evaluate, you tune. Right? This is a cyclic process that happens. And once this is done, you get the best model. Right? So this is the pipeline, ML pipeline. We call it as ML pipeline. Machine learning pipeline. Okay. Now, what all things are iterative here? What all things are repetitive in this case? Yeah, in this phase, in this flow, what are the various things which are repetitive? Yeah, friends. Naveen, Vijay.
Training.
Training, okay, let me mark that. This is repetitive, okay.
So are you talking about the whole end-to-end cycle or just this?
Yeah, I'm talking about the end-to-end cycle. These are all independent stages, right, Vijay? Everything can be independently performed. So out of all these different phases or steps, which of them are repetitive?
The tuning would also be repetitive because we have to tune it a number of times.
Yes, that's basically training only. Because of tuning, we are changing the training, right? We're redoing the training.
And the data processing also, pre-processing.
Hyperparameter tuning or optimization. This is something which is repeating. Okay, and you're saying data pre-processing.
Yeah.
Data pre-processing will not be repetitive, right? How is it repetitive? We're not changing the strategies, right? You're not changing. Let's say, for example, missing data is there. You're not repeatedly trying out the missing values, right? You're not saying that, okay, this time I'll run mean imputation, next time I'll run median imputation, next time I'll apply regression-based imputation. We're not changing those things, isn't it? That's not repetitive. But for hyperparameters, we keep repeating, say, parameter 1, value 1, parameter 1, value 2, so on and so forth. And we rerun the model. We change that, rerun the model. So rather than data pre-processing, we can say it's about the data ingestion, which is a continuous process. It is not a repetitive process, but it is a continuous process. And as the new data comes in, the steps will go through. Each and every step, we will be ensuring that it is applied onto your new data that is coming. So it is not a repetitive, it is a continuous job. Getting the difference from where I'm speaking?
Yeah, sure.
Yeah. Okay. Next, hyperparameter optimization is fine, but even before hyperparameter optimization, the machine learning models that we are going to select, we are going to repeat the training using multiple different models, right? So this is also something that we will be repeating. So ultimately, it is the training process which is repeated multiple times to get the best result, isn't it? Now, every time you execute a model, for example, ML1, you get certain results. ML2, you'll get, let's say, results 1, result 2. For ML1, again, you are going to alter the parameters. So you also want to record parameter set. Right? And what is the model? You might want to see the configuration. What libraries are there, versions of those libraries. So there are a lot of artifacts that you might want to capture. We call it as artifacts, the entire data and metadata. Okay. So on and so forth. You will be doing multiple such models. If you go to automated methods, there are hundreds of experiments which are done in your automated cloud-based tools, machine learning tools. Now, if you keep running it manually, how would you be able to track which model is the best model? Which of these is the best model? We'll not know, right? Unless until we keep everything in a proper place where we will be able to ensure that it can be compared and all that. We'll not be able to actually compare them if you don't capture the data or metadata and compare it. That give a provision to compare it, isn't it? So that's one thing. Now, once the best model is selected, you need to take that best model and ensure that you package it so that it can be deployed on any system. So it has to be independent. It has to be isolated. Isolated or independent are almost same. Let me not write isolated. I've already mentioned independent. So portable. That means I should be able to implement that model on any system. Secure, modular, so on and so forth. Different features will come into the picture that we need to consider when we talk about the best model. So we need to ensure that it is packaged together like an image so that the best model can be repeatedly used. It has to be repeatably used. Right? So these are some of the aspects that we need to look at. Now, MLFlow is specifically designed to track and maintain the entire ML workflow details, including the data. All right. So this MLFlow is basically used to track and maintain or monitor your entire machine learning workflow end to end.